And welcome to the Daily Space Weather. Yesterday we told you about a new sunspot having risen in the northeastern limb that you can see here in this imagery. That's pretty interesting. Early this morning we sent out a major solar flare watch to the SMASH team because of this rising region down here. That is a major sunspot group. It's already produced an M-class flare, which you'll be able to see here. There's a close-up. And the sun, frankly, is looking like it's about to jump into an extremely active state. We've got all kinds of plasma hanging out on the Earth-facing portion of the solar disk. We'll cover it and lots more on today's Daily Space Weather. And congratulations on realizing the SMASH News Network least busted name in news exists, where we take you straight to space. Here's a close-up of the two most significant sunspots on the Earth-facing portion of the solar disk. You'll see this M-class flare back here. And indeed, there is a sunspot that just rose down there in the southeast. Let's take a look at sunspots here. We've got some growth in the northern hemisphere as well. Some rapid growth. So that's a significant sunspot group also. It is quite magnetically complex, but the real group to watch is this group and this recently risen group. Let's show the colorized magnetogram. That is yesterday plus today. We also had a spectacular coronal mass ejection yesterday. We will also cover that. We'll even talk about the AMOC and about some citizen science that people like you can do from the comfort of your own home. And good morning, Tin Man 1057. Thanks for leaving a comment. And let's go over volcanoes. The current state of affairs is Suwanosejima is erupting and producing a 6,000-foot ash plume over the Ryukyu Islands. Semeru is exploding, flight level 140, over East Java, Indonesia. Dakono also exploding, flight level 070, over Halmahera. Katmai now back on the list. Located on the Alaskan Peninsula, it's exploding. It's a flight level 080, an 8,000-foot ash plume. Headed down to central Mexico, 24,000-foot ash plume from Popocatépetl. Fuego in Guatemala exploding, flight level 150. Flight level 230 over Sangay in Ecuador, also Revenador exploding, mildly. Please don't pole vault the caldera. No indication of the ash plume size from Revenador, but Cotopaxi in that same nation producing a flight level 230. It's a 23,000-foot ash plume. And Sabancaya is producing the world's largest plume of volcanic ash as it explodes, 27,000 feet. It's a flight level 270 over Peru. And let's look at global seismicity. Next, there's a 90-day graph. And we've got a great example of foreshocks leading to larger quakes. We talk about it regularly on the channel. The largest quake of the past 24 was this 6.0 in the Bismarck Sea. There is the location of that. North of Papua New Guinea there. And that came in at 1:05 this morning, Universal Time, 1:05 this morning on April 10th. So also we've been seeing some significant shaking here in this Nicobar Islands region, located on the eastern shores of the Indian Ocean. Those could be pre-earthquake signals. They may be what we call foreshocks. Micronesia also had a 5.3 yesterday. That was at 15:30 Universal Time yesterday afternoon. Also, there was a 4.0 off the coast of Oregon there. So Cascadia Fault Zone quake happening. And check it out. Here's another 5.2 at the Nicobar Islands region of the eastern Indian Ocean. There was also a 5.7 far south on the Mid-Atlantic Ridge. That was at 22:11 yesterday evening. That's 22:11 Universal Time. And check it out. There's a 5.8 magnitude foreshock preceding that 6.0 magnitude quake in the Bismarck Sea. So prime example there of an earthquake foreshock. Don't assume that the big earthquake is the last earthquake. There could be a bigger one about to happen. Sometimes you get some warning about these sorts of things. Also, there was a 4.6 near Point Possession place where demonic entities occupy human bodies. Point Possession, Alaska. Also, there's a 5.1 at Indonesia. That one happened at 0 dark 37, and then boom, 6.0 at Papua New Guinea. That was at 1:05 this morning again, and then of course you'll see aftershocks there like this 5.1 that occurred like only 4 minutes later. Also, Solomon Islands had a 5.4. And let's get back to space. This is the last 24 hours from SDO. That's 304 plus 335 angstroms. And I would note all the plasma reorientation happening. You'll see plasma moving around massively down here, over here, and up here around northwest of this sunspot. You'll see some of it splashing down and producing a flare. So, major solar uptick in effect at the moment. And here's a close-up of this southeastern limb, which is where it's at the moment. And welcome to Solar Cycle 25. That little lull in solar activity, as forecast, is not going to last. The 10.7 centimeter radio flux, which, by the way, is emitted from the upper chromosphere and lower corona, right about here on our imagery, is at 140 solar flux units. If you're wondering what a solar flux unit is, it's 10,000 Jansky of radio flux density. Jansky is a unit to measure radiation traveling through space. Anyway, 140 is the 10.7 centimeter radio flux number. That's a 1-year graph. The radio flux is reflected by the black line. The sunspot number is the red line. And the Space Weather Enthusiast dashboard here, not forecasting any geomagnetic unrest, but we just got to about geomagnetic unrest. So there's a coronal hole wind stream that arrived a little bit earlier than expected, like 2 days earlier than expected. And we'll get to that here in a moment. Let's take a look at Earth's magnetic moment from space. And the pressure environment has increased. We've seen an increase in the solar wind density, followed by a decrease in the solar wind density, and then an increase in the solar wind speed. So that's the typical signature of a coronal hole high-speed stream. Again, that's the last 4 hours of Earth's magnetic moment from space, modeled by the Space Weather Modeling Framework. It's croissant Earth, depicted over there on the right, the meridional plane view. Yeah, Earth's magnetic moment is shaped like a croissant with respect to an incoming solar proton. Croissant Earth. It's just a fact. And to quote Jerry Seinfeld, it's funny because it's real. Next, we'll look at ground magnetic perturbations over North America, since we did have a recent uptick here. We did share some auroral imagery just this morning on Twitter. Also, make sure you follow us over there. You'll find us all over the internet at Smash-O-Mash, if you weren't yet aware. And if you weren't aware, we weren't surprised. Anyway, this is the last 4 hours of North America's magnetic moment from the ground. The scale here is nanotesla, which is simply magnetic flux density. There you can see some likely upticks happening. And we'll also show the global view for all of you non-North American viewers. There is the global ground magnetic perturbations map. And this does, by the way, regularly happen with coronal hole high-speed streams. They are often showing up earlier or even later, or sometimes not even showing up at all as forecast. So that's what's going on with Earth's magnetic moment. The KP index last I checked was at 3.67. Now it's come down to 3. Why? Because the fields have weakened. So we're going to show that next. The real-time solar wind is measured at Lagrangian 0.1 outside of Earth's magnetic moment. And here you can see the solar wind density made it all the way up to about 35 protons per cubic centimeter. And then we saw the density drop off and the speed and also plasma temperature, which is this bottom frame, come up. Looks exactly like a coronal hole high-speed stream because that's what it is. Current conditions are just over 500 kilometers per second for the solar wind speed. Solar wind density about 10 protons per cubic centimeter. The reason we got out of geomagnetic unrest conditions is because of this top frame. You see that red line? That's the BZ. That's the vertical component of the magnetic field. And the field moved into positive territory. So when you see a strong negative BZ signal like this portion right here, that strong negative BZ, especially when accompanied by a strong magnetic field itself, which is this white line, that's the actual magnetic field strength, the entire magnetic field strength. When you see a strong BZ signal, that induces more currents into the Earth system and hence causes more geomagnetism. So at the moment, things have calmed down here. 10 nanotesla with a positive 2 BZ for the magnetic field measurements. Here are Earth's magnetic fields as measured by the geosynchronous orbits by the GOES 16 and GOES 18. Their geosynchronous orbits are at about 23,500 miles of altitude. And you see these sawtooth readings. Those are often characteristic of coronal hole high-speed streams. Let's take a look at the heliospheric current sheet next, as Earth is right in the middle of a North Pole current sheet. Welcome to the North Pole, folks. Welcome to the North Pole. The North Magnetic Solar Pole. You're in it at the moment. So that's our top view ecliptic plane field plot. And here's our line of sight field plot. The solar B field depicted here in blue. We showed you the Earth's on the geospace ground magnetic perturbations map. Here are the sun's B fields. The sun's B field, I should say. That is like the product of the north and south overlapping fields. The B field is the field that goes through the magnet, this magnet being the sun. And let's go to coronal holes next. Here's our coronal hole view. And we've got North Pole-oriented coronal holes here on the Earth-facing portion of the solar disk. No surprises to our regular viewers. We talked about it yesterday. No changes with coronal holes. Let's bring up the last image here and show the 211 angstroms wavelength from SDO. Now, you're going to see a lot of plasma reorientation happening, and I've covered up the time and date stamps just to give you a better visual of this. There you go. We can get just about the full disk there at that zoom. Come on, then. And look at all the plasma reorientation happening. Again, there was one spectacular coronal mass ejection yesterday and some missing data early today. So anyway, that's the situation. North Pole-oriented coronal holes here. A couple South Pole ones rotating out in the northwest. But the earthly effective ones are going to be North Pole-oriented, as you can see here. Next, we'll move to sunspots. And we'll have some new named groups. At least two new named groups. 3274 and 3275 just rose from the east. So here we've put up the SDO continuum plus 171 angstroms to help highlight the active regions. How about if we drop the 171 angstroms and zoom in? So these spots are mostly stable here, although we did see some significant growth with this one. It is quite magnetically complex. It's certainly beta-gamma class. We'll tell you toward the end of the space weather portion of the video if it's beta-gamma delta class. And you'll just barely see this sunspot peeking over the limb down here, and you don't even see it there, but this one up here will get an... Anyway, you get the idea. Let's move on to energetic particles and X-rays. So, no spikes in the proton flux despite seeing an M-class flare. We did see an M-class flare this morning. The peak flux was around 5:20 universal time, and that was an M2.77 class flare. Let's take a look at that in 94 plus 131 angstroms. So on your screen lower left down there, you'll see a bright impulsive flash. That is that short duration M-class flare. And don't be surprised to see an X-class flare. We do not know what is behind that sunspot. There could be more and more and more sunspots. And personally, I like the suspense. Why? Because the sun's not going to kill you or me. Now let's take a moment to look up. This is what's going on overhead Lehigh Valley, Pennsylvania. And you've got the Jupiter and the Sun. The Jupiter and the Sun very close together there near the ecliptic. The Jupiter just south of the ecliptic there. Planetary alignment. Lots of people are spooked, and let's talk about real science. Planetary alignments do not control the sun. So let's just move on with that and talk about Zooniverse.org. You never heard of Zooniverse.org? We covered it on previous videos. If you'd like to do real citizen science, check out the Galaxy Zoo. We need humans to help classify galaxies, as there are lots of calculations being done to do things like determine galaxy types, right? So the Galaxy Zoo allows you to just create a login, and then you can go in here and classify galaxies. So this one particularly this one's got features. It's not just, well, actually this one is kind of smooth, but it sort of does have features. So it's like a bulging elliptically shaped disc. We're going to say features, and we're going to say something else. Now wait, let's go back. Let's just say it's smooth. And it actually is cigar shaped. It does have a bit of a bulge there near the galactic core. Is it merging? It's not merging. It's not disturbed. And that's about it. And there you go. We've classified a galaxy on Galaxy Zoo. This does help actual cosmology. Galaxy Zoo, part of Zooniverse.org's Citizen Science program. Check it out if you haven't. If you want to do real science, that's one of the places you can do it. There's also the Solar Active Region Spotter, which this is actually new to me. I just checked this out this morning. We've only got 303 volunteers spotting active regions on Zooniverse.org. You're helping solar physicists to be able to study the long-term evolution of explosive regions in the solar atmosphere. This is vitally important for predicting when eruptions could affect Earth, as well as advancing our theories about how the sun works. So here's what's going on in the solar system. Here's your 1 week forecast. There's where things will be in a week. And Earth will be still close enough to the Jupiterian alignment that people will still claim that it's going to cause the dollar to be devalued by inflation. And also that it's going to cause Jeffrey Epstein's ghost to haunt all known government officials. So let's take a look at coronagraphs here. We've got some from yesterday, and a spectacular series of CMEs happened. Unfortunately, we're lacking data from today, so we may have to make another video, especially if we do have an Earth-directed coronal mass ejection. At the moment, it's not looking like it. We'll also show Stereo A's coronagraph. Sadly, the Soho Lasco C2 and C3, they end at about 22:30. So we brought Stereo A back to about 9 o'clock yesterday morning. That's 0900 Universal Time, when some serious coronal mass ejections began occurring. Those are not earthly directed, though. Again, we may have to make another video about additional CMEs. Oh, there's some good data from today. That's almost up to current times. There was an additional CME there from the southwest, and there you can see that propagating well into this morning. Does not look like it's earthly directed either. So let's continue on and look at filaments. Filament situation is there are some huge filaments on the Earth-facing portion of the solar disk. Filaments, filaments, filaments. Those dark absorption features They're blocking the ground-based solar observatory at El Teide, Spain, from being able to see the hydrogen in this great hydrogen alpha imagery. And here are some great wavelengths to show filaments. Again, you'll see huge plasma reorientations happening here, and the possibility of coronal mass ejections remains nearly 100%. Expect to see more, and expect to see large solar flares. We certainly do. Here at the Smash News Network, Least Busted Name in News, we like to use things like facts and science to make accurate predictions about what will happen with nature. So thanks for tuning in, and congratulations on realizing the channel exists. That's a 24-hour video, by the way. Here are the past couple of hours. Let's see what's been going on in about the past 2.5 hours. So there is our GOES 16 imagery. Did you know people from NASA are paid to just sit there and watch this and watch coronagraphs all day? Yeah, it's true, folks. As they do indeed have important assets, living people up in space who actually can receive a fatal dose of radiation. And if you're viewing the videos from space, hey, thanks for tuning in. We may have to come visit you in the coming couple of years. That's the past couple of hours, about 2.5 hours from the GOES 16 SUVI with its great wide field of view. And for the past 2.5 hours, things have been fairly quiet, despite a major sunspot group rising in the southeast. Let's continue to bonus features here. We've got some satellite charging hazards over the central Pacific Ocean. Those are significant surface charging hazards there. That is the effect of low-energy electrons building up on the outsides of spacecraft. Could cause some minor errors there on satellites over the central Pacific Ocean. GOES electron flux here is cratered, as you may have expected if you were expecting a coronal high-speed wind stream. We weren't expecting one for about 2 days, but we have one nonetheless. So there's that characteristic cratering of the GOES electron flux. And this forecast model will be way off. This will be down here somewhere. That's NOAA's forecast. The green boxes are the forecast. The yellow diamonds are the observation. And there's the 1-year graph to put it in context. Again, we can expect to see this dip down to about here. Maybe even, well, I won't conjecture. Next, we'll show the F layer of the ionosphere, which is where that electron flux gets measured. Feel free to pause the video on this frame if you're not familiar with temperatures, chemical concentrations, and electromagnetic radiation penetration of layers of the atmosphere. And behold, the troposphere, the portion of the atmosphere where people see contrails and they think it's chemtrails because they don't understand basic physics or what geoengineering is. So they see contrails. They live near an airport, and they're like, oh no, they're spraying again, which tells them something about the atmospheric conditions, not about the plane's actual exhausts. Anyway, here's the F layer of the ionosphere and its vibrational frequency. And if you're not familiar with the imagery, don't worry. We show the anomalygram as well. So there's the anomalygram showing anomaly in megahertz from a 30-day median. High-frequency anomaly in blue, low-frequency anomaly in red. And we do have some major anomalies there over the Eastern Pacific and North America. So some significant low-frequency anomalies there. Let's show the latest image. There's 12:15 universal time ionogram and 12:15 universal time anomalygram. We'll also show the total electron content. That's the free electrons up to your GPS satellite. Feel free to pause on this frame if you're not familiar with distances to various things in miles. Here's the global total electron content forecast. Also shown daily on the channel. because you never know when you're going to amass data that's going to give you answers to questions not asked. That's what happened to me. I wasn't trying to explain the solar cycles, but through a process of induction and deduction, I believe I've determined the actual mechanism that causes them. Anyway, here's the North American total electron content anomaly from the 10-day average. And once again, we're seeing some low electron contents. Anyway, last but not least, we'll show the latest intensitygram and the latest solar magnetogram. So this new sunspot down here. Oh. There we go. Now we get both on the screen. That's perfect. So there's 3272 in the upper right and 3274, I believe, in the lower left. I only see one umbra so far. I suspect that is a beta gamma delta class sunspot, though. I think you'll see some more umbrae rising. Let us know in the comments what you think. You think it's an alpha class or a beta gamma class or a beta gamma delta class sunspot? We're interested in your forecast. This group up here is beta gamma class, at least. There is one small trailing South Pole umbra, just making it beta gamma class. This one here is certainly nothing to sneeze at. There are the fields of that sunspot. That's barely beta gamma delta class. So propensity for large solar flares is very high. Expect to see additional M-class or even a possible X-class flare. We're going to get to meteorology next. First, take a moment to visit the links below the channel. Below the video, that is. If you're viewing on BitChute, make sure you go subscribe over on YouTube. You're missing like 90% of the content. Today's featured product is Project Management Facts. Now, a little bit about the channel. Our channel is in this area right here, number 1. It's good and fast, but not cheap. Hence, the videos come out daily at massive personal risk and expense to us. So please support the channel. You can tell your friends and foes about Product Management Facts. It can be cheap and fast, but not good. It can be good and cheap, but not fast, or it can be good and fast, but not cheap. Those are your choices. Any project manager who thinks any project can be good, fast, and cheap is not worth their salt. That is a hacky project manager. So perhaps pick up one of our t-shirts, or maybe a hoodie, or something like that, and go tell people about this basic project management fact. You don't get all three. That doesn't exist in the real world. Nothing is cheap, fast, and good. So let's talk about the AMOC, the Atlantic Meridional Overturning Oscillation. The Atlantic Meridional Overturning Circulation, the AMOC. And what that is that's a conveyor of warm and cold water exchanging itself in the Atlantic Ocean. Warm water goes this way, cold water goes this way, and it takes about 1,000 years for 1 unit of water to make it through the circulation. So it would be very tough to really actually see this happening. But the geologic record tells us that when the northern hemisphere freezes, the AMOC shuts down, and that causes Europe to get cold, and then it causes Asia to get cold, and then it causes North America to get cold. That just seems to be the mechanism that causes it. I mean, it's just, the geologic record doesn't lie, but lots of people on YouTube do lie. So we'd like to show the Gulf Stream here because it's partially responsible for this AMOC. the Atlantic Meridional Overturning Circulation. So what we're showing here is ocean currents and sea surface temperature. The ocean currents are the animated portion. The sea surface temperature is the shaded portion, the colored portion. And basically what happens, folks, is that fresh water from Greenland makes its way down here. And essentially what it does is, for the northern hemisphere at least, and this is something that I came home in about 1987 after attending Earth Science class in 8th grade, and I told my parents, were you aware that global warming causes global colding, at least in the northern hemisphere? Oh yeah, that's a thing. Anyway, so we like to show that daily because there are maybe not as many global cooling alarmists on YouTube, but there are certainly plenty of global cooling alarmists and certainly plenty of global warming alarmists. The basic facts are that the planet has been much, 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 much colder for the past millions of years, and the Earth has been much, much, much hotter during 90% of the Holocene. So anyway, that's the current situation for sea surface temperature anomalies. You can see both cold and warm water all mixed together there. And also keep in mind that fresh water sits on top. If you've got water that's the same temperature, and you take fresh and salty water and you mix them together, the fresh water will sit on top of the salty water because salty water is more massive than fresh water. Anyway, let's move to meteorology here, since we've cited some facts that'll probably offend somebody. Here are the surface winds of the eastern world. Here are the jet streams of the eastern world. If we've offended you with facts, we are terribly sorry. Please leave us a comment and express your anger and rage. We're extremely sorry about that. Terribly, terribly sorry. Although it was a goal. Still got some backward jet stream here over the western Pacific. Nope, it's not going to reverse Earth's rotation. Nope, it's not going to rapidly shift Earth's axis. Here are the jet streams over the North America and South America, and check out the huge jet stream trough here. Cold air making its way all the way down to Texas. And here are the surface winds. Strong onshore winds there on the Florida coast. Here are the surface winds of the central world, Europe, Africa, and the Middle East, and there are the jet streams. Those are your global weather patterns. And if you want to read about the Atlantic Meridional Overturning Circulation, there's an article about it from NOAA. oceanservice.noaa.gov. Just type in AMOC and you'll find it pretty easily. We used DuckDuckGo. And we'll even briefly scroll the article here in case you want to watch it via the video. So here's the sunrise over the Atlantic. We brought up the visual satellite today because we came at you kind of late with today's daily space weather video. Sorry about that. If you're mad about that, leave us a comment. If you're completely neutral on the content, leave us a comment. If you hate Smash Staff and I and you want to see us dead, leave us a comment. Next, our weather.gov map, and look at all the flooding. That's all hydrologic output, that light green. And there are some flood warnings up there. Major flooding as a result of melting snow. Is it going to shut down the AMOC and create a year without a summer for the Northern Hemisphere? I doubt it. If your location is lit, click your location. We've scrolled down to show you the key. That's about the extent of what we'll do for this meteorology segment. And let's move on to some forecasts. First, the snow extent. So snow extent here is right in the middle of the standard deviation range. As you can see, that's the standard deviation, the blue area there. The area between these blue lines is a standard deviation for the 1998 to 2011 average, which should probably be updated, by the way, especially since we've had 7 consecutive winters of record snow in the Northern Hemisphere. Here is snow mass balance, not including mountains, which is right at the upper range of 1 standard deviation above the 1982 to 2012 average, and the snow water equivalent is the really relevant feature here. As anomalously warm temperatures are coming to the northwestern U.S., you can expect to see this continue to drop suddenly and flooding to continue. So just be aware of that as, look at how high the snow water equivalent for the Northern Hemisphere indeed is. At least it's finally dropping, but it's nowhere near the plus or minus 1 standard deviation for the 1998 to 2011 average. That's a lot of snow that's a lot of water in the form of snow just waiting to melt. And it shall. And it is. So here's your forecast for temperature anomaly. And check it out. Anomalously warm temperatures will be in a huge band stretching all the way from California to Maine and beyond. Those temperatures will be like 12 degrees Celsius above normal. That's your GFS 72-hour temperature anomaly forecast in degrees Celsius. Here is your GFS 72-hour total accumulated precipitation forecast. There is some severe weather coming to New Orleans, although it looks like it's going to not hit as directly as the forecast was yesterday. Again, that's your 72-hour GFS total accumulated precipitation forecast in inches. And we'll also show the pressure and precipitation forecast based on the same GFS 72-hour model. We show 72-hour models because they tend to be accurate. We don't show like 3-week forecasts and look like complete weather dolts. And by the way, we think it's entirely ridiculous for people to forecast the climate for the next 50 or 100 years when we can't even forecast the weather for 4 days ahead. Why? Because there are variables missing on the models. Yeah, variables missing on the models, like sudden stratospheric warming caused by things happening in the ionosphere, cloud cover, cosmic ray flux. It's kind of important. But that's what we expect to happen based on a GFS 72-hour model with your weather. It looks like those strong storms might largely miss the Louisianan, Mississippian, and Alabaman and Floridian coasts. Let's hope it keeps moving to the south on the forecast. Next, windy.com, by the way, they have this interesting extreme forecast. So that's another interesting feature of windy.com. I was just trying to decide what to show people like you today, and I figured I'd show this one. It's one of the more obscure things. I mean, there's the extreme forecast for wind. Here's the extreme forecast for temperature. Look how hot it's going to get in Montana. There's going to be a lot of snow turning into water. Also the Great Lakes region there. Also Idaho, parts of Oregon. And there's the extreme forecast for rain. The Pacific Northwest, expected to be kind of moist. Next, we'll look at lightning. This is the past about 10 hours. And that is jacked up. Let me press refresh. There we go. Some strong lightning in Texas and Nebraska, also Iowa and Missouri. Here's a real-time lightning map. And it looks like we may have some terrestrial strikes here. Looks like a little thunder shower here just north of Kansas City. Nothing too major. Once again, if you enjoy the content, please support the channel via our links. You'll find links below the video to our Hemp Lucid shop. Don't forget to enter the promo code SMASHOMASH to save some dough. These videos are brought to you, again, at massive personal risk and expense by Smash staff and I. That's the whole operation, just us two. So improve your health, perhaps, by trying out some Hemp Lucid products. All kinds of different solutions available for you there. Enter the promo code SMASHOMASH to save some dough on checkout, or just use our link, which is clickable below this video in the description. You can also find it on our homepage at SmashOmash.com, the official homepage of the Smash News Network, least busted name in news. And Smash staff and I would like to welcome you to the Neo-Renaissance. It is an awakening of people objectively viewing facts and being critical about basic science. Smashomash.com is the homepage. All kinds of links there if you want to send us an instant message. Send us an instant message via our Discord chat. There's a permanent invite link to the Discord chat right there. That's what the icon looks like. Right there. That's the Discord chat. You need an invite link, and we put a permanent one on the homepage. And if you want to support the channel via subscription services, become a member of the Smash team. You can sign up for email alerts without paying us a dime at the bronze level. There's also a gold and a silver level. The best value is the gold annual paid-up subscription. Thanks to our Smash team members, these videos were brought to you in part by not only our patrons, but also our Smash team members and viewers like you who've done things like press the share button, especially if you're an influencer. Thanks to everybody who has supported the channel throughout the pushing 6 years. Smashomash.com/Smash Team is our own custom subscription services site. We'll close out the video with the U.S. Doppler radar map. There are the full 50 states of AUSA, the allegedly United States of America, former nation, banana republic since about 2015, in my opinion. Why? Why do I think the U.S. became a banana republic in 2015? Are you wondering? Well, here's why. Because the press made it obvious that there was no such thing as journalism. Journalism died by 2015. Yeah, by 2015. Not because Trump got elected, because Fox News could not objectively cover the election and the run-up to the election and so on. They made it obvious that they were in bed with Trump, which we found unacceptable. Journalism died by 2015, and the U.S. has been a banana republic ever since. Here's the lower 48 view. Here is, oh noes, we've got a crashed browser, folks. Now, this has been a thing that's been happening. We may have to stop using Brave. This is Brave browser, by the way. It just closed down just out of nowhere. I mean, I just simply tried to go to the next tab, and it was like, nope. Don't worry, folks. We'll get up the information for you here. Just give me a moment. And while we get that loaded back up, take a moment to visit our website, smashomash.com. Hit us up on social media. Tell your friends and foes about us. We don't believe the content is being particularly recommended by organizations like YouTube, Twitter, and Facebook. Okay. I've changed my mind. We are scrubbing this video and probably the use of Brave browser also. Brave browser, you're fired, okay? Oh my gosh. What the kind of is this? It's making me into an angry space rager. Anyway, that's where we're closing things out. We'll see you soon. Congratulations on realizing the channel exists, and may that solar wind be at your back.